All right, this is lecture 20 on replicability, generalization in the real world, and this closely follows the chapter from the Moorling textbook. So, replication just means reproducible. And this is very important in science, in psychological science, in social science, but really all science, to know that a particular result of a study can be reproduced. That gives us faith that the effect, the phenomenon, is a real one. What the chapter reviews and what I will also review is that there are three types of replication studies, either direct replication, conceptual replication, or replication plus extension. And I'll go over these and give some examples, again, following the textbook. So with a direct replication, sometimes known as an exact replication, the original study is repeated as closely as possible to determine whether the original effect, the original finding, is found with new data. In this example that was given here, the researchers theorized that because most people like themselves, they might implicitly associate positive feelings with the letters in their own name, as well as the numbers in their birthday. And so they further hypothesized that people might be attracted to people that share their name, their birthday, or their initials. So to test this, they completed a short survey about, participants completed a short survey about themselves. And then each participant was given a page of responses from somebody that they believed was a randomly selected partner, another participant, another randomly selected participant in the study. At the top of the page was the partner's ID number printed in a large font. Now, for half of the participants, their partner's ID number had been matched to their own birthday. So they're looking at that ID number and they're saying, oh, that's my birthday. For the other half of participants, it wasn't. Okay, so it was just a number that didn't match. The other information was completely identical. So the actual responses that they're reading, which was the exact same survey that they completed, was completely identical, okay, whether the ID was a match for their birthday or not. And so the only difference was whether the ID was a birthday match, which you see in these black bars, or not, which you see the gray bars as the control. So then after, and again, this is a completely bogus thing. It's made up. Deception was used in the study. Okay, it's a use of deception. But after reviewing these responses, participants were asked to rate their partner on several dimensions. So as you can see in this graph, when the partner's ID matched the birthday, participants liked the partner more than when the ID didn't match. And so what the researchers did is they just replicated that exact same study another time. So you see study 5A and study 5B's. They did multiple studies in the original research manuscript. So this is just pulling out study 5 and study 5A and study 5B. Okay, but this is just to show. So for instance, when they submitted their research to a journal for publication, it could have been the case that the editor of the journal said, hey, I'm not so sure about that finding. Do it again. Make sure you get the same result. And they're like, okay, I guess we'll do that. Or maybe even before trying to publish, they're like, nobody's going to believe us. Nobody's going to actually believe that this ID birthday match thing is like a real thing and it would actually make a difference. So let's just basically do the experiment and then let's do it again so we can show that this effect replicates. It will give people that read our research more confidence that this is a real effect. Okay, so that's one example of how a direct replication is done. You just repeat the study and some of the motivation. Now, it should be stated that although direct replications can make a lot of sense when you're just really trying to emphasize, hey, this is a reliable effect, it should be noted that you also run the risk of repeating whatever threats to internal validity or construct validity were in your original study. So if you do everything the exact same and there's issues with the first study, those will be present in the second study. So, and sometimes that happens. There's the expression that hindsight is 20/20, and when you start out and you're designing a study, you try to think of every possible issue. You try to come up with the best measures of your constructs possible. You try to come up with the best manipulation. But then in doing the study, you ultimately learn more information. And so sometimes a direct replication isn't the best thing, but rather something called a conceptual replication might be the best thing, which is to say, look it, we did the study and now we're going to do a similar, not the exact same, but a similar version of the study. And we're going to make a couple improvements and we're going to measure our outcomes a little bit differently. And we think actually that if we can get the same general pattern or the same general finding, that is actually stronger because we've improved on what some of the previous limitations were, whether that's internal validity or construct validity. Okay, so here's an example of that, which is known as a conceptual replication. This is when researchers explore the same research question and test similar hypotheses, but they use different procedures. The conceptual variables in the study are the same, but the procedures for operationalizing those variables might be different. So this was in the chapter, but consider the theory of implicit egotism, which is basically that people's implicit, that is kind of unconscious, unaware, self-associations predict their social behaviors. Okay, so that is if people kind of are just naturally somewhat egotistic, are naturally somewhat self-referential, okay, that should predict behaviors. So researchers operationalized the concept of implicit self-association as basically the degree to which something is similar to the self. So either through looking at people that share the same first name, or looking at people that share the same last name, or having people or partners in an experimental setting that share the same birthday. So you can look at similarity to self in a couple different ways. Okay, you can operationalize that slightly differently. And then in terms of social behavior, in terms of what does similarity to the self predict, you can look at, as the study that I previously reviewed, you can look at attraction to a person, like overall likability, okay? So does similarity in birthday, is that related to the amount of attraction or liking that we feel to a person? But if this is a real phenomenon, there should be broader effects. And so, indeed, what some of this research finds is that people named Denise or Dennis are more likely to become dentists than lawyers. Okay? So the idea is that dentist starts with a D. My name starts with a D. So therefore, I implicitly kind of like or am attracted to careers that are more similar to my name. Sounds like a crazy finding, doesn't it? But indeed, that's what their research established. Okay. What about other things like even living in a city or a state? Some of this research has found that people that were born on February 2nd, okay, 2nd, are more likely to live in a town called Two Harbors versus Three Forks, but the opposite for people born on March 3rd, okay, so 3rd, Three Forks. So really having all of these conceptual replications, you can think of kind of a strength of evidence for the phenomenon. So rather than simply replicating the exact same study, where the researchers look to see through direct replication whether having similar birthdays leads to more liking or attraction for a person, showing that the same general pattern replicates using these conceptual replications, different operationalizations of similarity to the self, and then different phenomena like pursuing a career to be a dentist versus a lawyer, or living in a particular city, really provides stronger and a broader base of evidence for the psychological phenomenon. So that is the benefit of a conceptual replication. Okay, another type of replication is known as replication-plus-extension. This is where researchers replicate the original study, but also add some variables to test additional questions. So we, in my lectures, I've previously reviewed research that has looked at taking notes on a laptop or writing it out longhand. And generally what that research has found is that when people watch, in this case it was watching lectures on TED, when they write notes longhand, they have stronger performance in general than when they do that on a laptop. In the original study, the researchers noticed that when people used the laptop, their notes were more verbatim overlap with the lectures compared to longhand note takers. In other words, on the laptop, they're just trying to write down word for word what the speaker is saying, whereas people that wrote longhand had to summarize points more. Okay, you can't write so fast, so it's really difficult to write word for word. So they had to summarize things more and use their own language, use their own understanding. So the researchers suspected that the laptop users were just like transcribing, and so they weren't really processing the information as deeply. They weren't thinking about it. They weren't making the connections. And so therefore they performed poorly when tested. And so in order to, based on the finding from the first study, they had this insight, and then so they said, oh, okay, so in this a follow-up study, what we're going to do is we're going to create a new laptop condition in which people are warned not to copy the lecturer's words exactly. Okay, and so that's this kind of I don't know what color we call this, light pink or peach color perhaps. Okay. So that was a new condition, but they were able to compare and contrast the results based on the original condition of their study, which was just use a laptop without being provided any additional instructions, and then being provided a laptop, but now this new experimental condition. So it's a replication because the two original conditions of the experiment were present, but they added a third condition. So it turns out that the laptop condition that we're warned not to copy verbatim basically contained the same level of verbatim overlap as laptop users with the original instruction. And in addition, both laptop groups performed worse on the test questions. So it could be, and I have to say this is in some respects consistent with some of my own experience, both as a research psychologist as well as an experimenter. Sometimes the experimental manipulation is simply to give participants instructions, and participants really have a way of not following instructions so well. And that could be because of the populations used, college students, etc. It just could be that, behavior is so ingrained on the laptop that it's very difficult just for a verbal instruction to get people out of that habit of how they're used to using a laptop. So, and another way to conduct a replication plus extension is to introduce a new independent variable altogether. So in this extension, there's still, you could say, one independent variable, which is the method of taking notes. Okay, so a single independent variable. But you can do a replication plus extension where you add another independent variable altogether. And so these same researchers did another study that illustrates this approach. They thought that the verbatim notes of the laptop, so the people that use a laptop and they were just writing down, kind of transcribing everything that the speaker said, that might actually be more valuable if students were allowed to study the notes before the test. So researchers assigned people to take notes using either laptop or longhand, but this time they were tested on the material either 1 week after the lecture, and this is closer to what you find in a real college class. And then upon returning to the lab the following week, they were either allowed to study the notes that they had taken the week before or not. And so therefore, this was a 2x2 factorial design. Note-taking was one independent variable, and whether they were able to study was the other independent variable. And so what you can see is that the condition that performed the best were longhand notes with the chance to study. Okay, here, having this weak retention interval where longhand notes didn't have the chance to study, their memory for the material is not any better than laptop notes with no chance to study or a chance to study. Interestingly, laptop notes with a chance to study is still not as good as longhand notes with a chance to study, and not necessarily any better than longhand notes with no chance to study. So I thought that was pretty interesting to the extent that these findings can be generalized to college classrooms. Is being in a classroom and just trying to be on the laptop and furiously type everything that the professor is saying, and then think that you're going to go and take those notes and try to understand them and cram before the exam, doesn't necessarily suggest that would be, just because you've got all the words, it doesn't mean that that's any more useful to you than if you just free-handed the notes but then didn't even study at all. And then certainly free-handing the notes or long-handing the notes and having a chance to study is the best. So anyway, I thought that those were interesting findings. So why is all this replication important? Why do these replication studies in the first place? Part of it is the replication crisis that has been found in psychology, but the replication crisis is not unique to psychology. It's been found in many other fields as well, from medicine, biology, chemistry. And in psychology, part of this, what had been labeled as a crisis, came from a large group of psychologists collectively known as the Open Science Collaboration that attempted to replicate several findings on a systematic scale. So what they did is they selected 100 studies from 3 major psychology journals. I believe Psychological Science was one, as memory serves. I think Journal of Personality and Social Psychology, and I'm forgetting a third. They took 100 studies from these 3 very good journals, and then they recruited researchers from around the world to conduct direct replications of the published study. It said, hey, just follow the methods that the authors of the study reported, try to replicate it as closely as possible. And then they used different metrics to determine whether the study was a successful replication. So one of the metrics is if the previous study got a statistically significant result between conditions, did the replication as well. Okay, so by one of these metrics, only 39% of the studies clearly replicated the original effects. Okay, so that's the one that there were other metrics, and it kind of depends what you use, but this is the one that is commonly cited. So this became known, or started being described by journalists that write about science as the replication crisis in psychology, which is that, if we take it somewhat literally, it would be that only about 1/3 of the published research findings replicate. And so that gives us concern that when we're reading a study, the effect is not necessarily consistent or reliable. So therefore, is the phenomenon actually real? And there's enough momentum in psychology behind this open science collaboration to say, yeah, we should do this. We should try to replicate these studies, because there had been rumblings for years before, like, hey, there's kind of some wild stuff getting published here, and we just don't know if it's true. And we want to be a science that when there's published results, we want to be able to trust it. And so this ended up being very damaging, I would say, for the field. Although, again, it should be noted that psychology isn't particularly unique with a failure to replicate. It is found in other fields as well, but it is certainly an issue in psychology. And by the way, I was trained as a social psychologist. I've really come to question many of the findings from social psychology that I previously put some faith in. And I will say, even though I do it from time to time, I am very, very cautious about citing the results from a single study. It is only when I have seen a phenomenon be replicated through either direct replication or conceptual replication several times that I start to think to myself, yeah, there's probably something here. But a single study showing evidence of a new phenomenon, I'm a little skeptical, I have to say. And I was before, but this open science collaboration and the work of all these research teams made me particularly so. Now, to be fair, there are reasons why studies don't replicate. And I think it's worth talking about those. And I think the textbook author does a very good job reviewing these as well. Okay, so because I can tell you, I have published papers, and if a research team took my exact study, did everything that I did, different participants, different time, and tried to do it, I think that there's a chance that it might not replicate. Okay, so there's a chance that my own work couldn't be replicated. Okay, I don't know what the chances are. I'm not saying it's necessarily a good chance. I think it probably could, but that there is a chance. And so why could that happen? Some of it has to do with what are known as contextually sensitive effects. So some of the measures, the way that we measure variables, and some of the experimental manipulations that are used in replications may not have had the same meaning as in the original study. Okay, so as one example, in one original study, they were looking at how people respond to requests to donate to charity. In the original study, the researchers had mailed actual letters about an AIDS-related charity, but in the replication, they sent emails instead. And instead of being about an AIDS, HIV-related charity, it was about an environmental charity. Another original study had Stanford University students watch a video about diversity-related admissions practices, okay, like using, race, ethnicity, gender, etc., as in making admissions decisions and practices. The replication study used the exact same video, but in the Netherlands, where the ideas about diversity, affirmative action, etc., don't necessarily apply. So, two things. One, in the first study about donations to charity, It's unclear why the replication didn't do the direct replication. It did a conceptual replication, but it turns out that those were non-trivial decisions. There seemed to be something special about getting a letter in the mail about an AIDS HIV charity, and participants' donation behavior differed when instead they got an email about an environmental charity. And it kind of makes sense, right? How many emails do we get? We're all just flooded with emails. It's really hard to look at an email and all the requests that we get and sometimes take it seriously. So there's something special about getting the letter in the mail. And in many ways that kind of, speaks to the generalizability of the effect. And that's fine. But it doesn't necessarily mean that there was a problem with the original study. It just means that perhaps the phenomenon and what we know about people giving to charity is somewhat bounded, and we can understand differences in behavior when the request is made by getting a letter in the mail or email. And the other replication, okay, it's the exact same, we could say, materials, like it's the same video on whether, diversity related issues in college admissions, but you kind of like transplant that to a completely different context, Europe and the Netherlands, and it doesn't even have close to the same meaning. So there, even though it's more of a direct procedural manipulation, it's completely out of context. So yeah, sometimes replication studies fail. They don't get the exact same effect for these contextually sensitive effect reasons. Another issue has to do with the number of replication attempts. So the Open Science Collaboration conducted only one replication attempt for each original study. Okay? But it should be known that any single study always has the potential to miss a true finding. So even though the finding could be true and you could still not replicate it, and that could be due to things like sampling error, the idea that in statistics, I hope that you had learned and remembered about something known as a type 2 error, that is concluding that there's no effect when there really is. So that can happen. And in any single study, you can have a type 2 error. Okay, in the statistical language, we fail to reject the null even when we should have. We failed to say that there was a relationship between two variables or a difference between experimental conditions in our study, even though there really is, say, in the population. So that can happen. So the way to get around that, of course, is that you want to try to replicate a study not just once, but many times. And so there's something called the Many Labs, the Many, M-A-N-Y, Many Labs project, which conducted up to 36 replications of each study and then combined the results of them all. Okay, and so using this more powerful approach, replication rates rose to about 85%. So rather than having only a 39% replication rate, the replication rate there was more like 85%. Okay, now that's a lot of effort. And so, in selecting which studies ought to be replicated, I think it's worthwhile to pick the ones that are perhaps the most important findings. Okay, so in some ways, this work is done to say, in general, when we're reading research, what's our level of confidence that any particular study could be replicated? Okay, that's on the one hand. On the other hand, I think it's important for the field of psychology to say, hey, what are some of the most important effects out there? And we should make it standard practice, not by a single research lab, but by multiple research labs to try to have many replications of those findings. And a research journal could encourage that by actually requesting or soliciting replications for certain studies. Okay. And then, of course, this is maybe what we think about, is some replication studies fail because there's problems with the original study, okay? So we can think about these first two as not necessarily being problems with the original study, but now let's think about what first comes to mind is that there could be problems with the original study. And one of the first ones is that the original study's sample size is too small. And so it could be the case that there's some, there's a small number of participants that are kind of unusual that had a disproportionate effect on the results, okay? And that when you get a larger study and more people, the effect is either really, really small or not there at all. So we could think of this in some ways as being a type 1 error, that a small sample size getting a significant finding could merely be a type 1 error. Now there's a low probability of that. Okay, using our conventional statistical methods, there should be less than a 5% chance of getting a type 1 error, that is, saying that there's an effect when there really isn't, but that happens. With all the research that is being done across all the colleges and universities, there's plenty of opportunities in the aggregate to have many type 1 errors. And so it could be the case that a lot of the studies that are being published, the researchers got the result. They absolutely and totally did. It just turns out that what they're publishing is a type 1 error. All right? So that could happen, okay? Completely ethical and honest researchers that have a small sample size could have just through sampling error got an effect which they believe is real, but it really isn't, okay? Now, then, of course, there's cases in which researchers do things that aren't particularly ethical and are a little bit dubious, okay? Now, one of these practices is known as harking. And actually, I wish I would have capitalized the A, the R, and the K because it's an acronym that stands for hypothesizing after the results are known. Basically, this involves creating a hypothesis after seeing the results. So sometimes there's a surprising result that doesn't necessarily have anything to do with an established theory, or isn't necessarily something that the researcher hypothesized ahead of time. But it's like, oh, okay, well, now that I've done the data and now that I see the results, I'm going to create my prediction. I'm going to reverse engineer my prediction. And this is a problem because the study findings could just be due to, these could be the type 1 error findings, right? They could be due merely to sampling error or random chance or noise in the data. So by harking and saying, oh, we knew it all the time. We didn't really, but trust us, we knew it all the time. These were our hypotheses. We expected to find this. Trust us, okay? And then you convince an editor and other peer reviews, and then it's published, and then it's out there in the literature, and it's like, that's funny, we can't replicate it, okay? Because it's one of these erroneous type 1 error studies. Another dubious research practice is something known as p-hacking. This is when a researcher peeks at the study's results, and if they're not quite significant, they say, well, let me get just a couple more participants, peek at the data, is that significant yet? Oh, not quite yet, let's just do one or two more. So it's really capitalizing potentially on chance factors or error, potentially hoping that you've got an outlier or two that are in the favor, like in the pattern of the results that you're hoping for. Alternatively, another way to when we're talking about p-hacking, we're talking about that magic p less than 0.05. That's the magic threshold that if we can just get a statistically significant result, when we do our statistical tests, our correlation, our t-test, our analysis of variance, whatever it is, and when we plug in the numbers, our software spits back at us, this result is p less than 0.05. That is, it would happen less than 5% of the time if the null is indeed true, right? So there's all different kinds of ways that researchers can kind of hack that process. And one way is kind of this selective collecting of data is like, well, let's get like a minimum number of participants and see if it worked. Not quite there. Get a couple more, run the analysis. Did it work yet? Not quite there. Run a couple more participants, see if it worked. Oh, we got it. Good. Stop. Don't run any more, because the effect could go away. Don't run, the idea is like, oh, good, we got the effect. Let's run more participants and make sure that this is real. That's not what happens. It's let's stop here because we got the effect and we can say we got the effect and we really need to get this effect so we can publish it. So let's stop. Don't mess it up. Okay? And then the other way you can do that is to look at the data and maybe be a little bit liberal with who you consider a statistical outlier. Say, I don't know about that data point. That data point is not in the trend of my other data, so I don't like it. I'm just going to remove it. Okay? And in some cases, that could be legitimate and acceptable, and in other cases, it's not. But these are ways in which that researchers can p-hack their data to get a statistically significant finding. Okay, and you might recall, if you remember or you read about it, that p-hacking was something that Amy Cuddy's co-author, who was actually the lead author of the study, said that they did. They engaged in p-hacking to get the result for their very famous study that then became the basis of the TED Talk. All right, so this is from the chapter, but I think I just present these tables just as kind of a review, which is just to say, why is it difficult to replicate studies that were originally published? Okay, there's a couple different possibilities. It could be that there's problems with the replication attempt. So there's not necessarily anything wrong with the original study, but there's problems with the replication attempt. Okay, and so these again are capitalized, really focusing on the ideas of contextually sensitive effects or not a large enough sample size. Okay, there can be problems with the original study. This is what first comes to mind. Okay, they use a small study or they did questionable research practices. Okay, and so kind of why it's an issue and what can be done. And then another thing that we haven't yet talked about is that the kind of third factor here that is associated with the replication crisis is that academic journals are in some ways to blame. And part of the reason is because scientific journals prefer to publish new findings over replication studies. So there's kind of no incentive on the part of a research team to look at other people's work and say, hey, we're going to make sure that that's a real effect. We're just going to have 3 high quality replications of that original study. It'll never get published. So why do it? Okay. And before the open science collaboration, I think that was the kind of the building momentum, is this recognition that there is, kind of decades and decades of research that is starting to accumulate, and we're not quite sure how much faith we can put in certain findings because nothing is ever replicated. It's this push for new findings. So it's like new finding, new finding, new finding. It's like there's all this new stuff. Is there really all this new phenomena? I don't think so. I think a lot of, anyway, I'll just cut myself off there so I don't start getting on a soapbox. But it's journals often chase novel findings over replication. And in pursuing those findings, there is absolutely a bias towards significant findings over null effects. Okay, so a research team could have a perfectly executed study. They have a strong theory, a reasonable hypothesis, a large number of participants so that there's plenty of statistical power to find a relationship or to detect a difference when one really exists. They've been thoughtful about their methodology, about their operationalization of their constructs, and they could get a null result. And in some ways, you might say, oh, wow, like that is actually a significant contribution. Like when we look at the preponderance of the evidence, we've got some studies that found an effect and some studies that didn't. And wouldn't we want all of that as a part of the scientific record in order for us to really get a strong sense of how strong is this effect, how consistent is it, how replicable, what are some of the boundary conditions, like in this well-executed study, is there anything different about this study than the other ones? But that's not what happens. Well-done studies that find null effects are not published. They go in a file drawer, when we used to have file drawers names like paper and stuff like that, okay? Whatever the metaphor is for on the computer. They go in that folder on your hard drive that is like, you'll never to be seen again. Okay, I unfortunately, woe is me. This is a sad story, isn't it? All the experiments that I've done that became nothing but data sets and files in a place on my computer, never to see the light of day. All right, whatever. So that happens. There's a publication bias in psychology. And in other fields, but we're picking on psychology. All right, so what can we do to make things better? Seems like a no-brainer, but large samples. So research journals that want to publish data should really require larger samples, both for the original studies as well as for replication studies. So there can just be more confidence that the effects are real when it's based on larger sample sizes. It's really important as well to report all the analyses and the variables that were tested. This was something, again, that Amy Cuddy's co-author mentioned, which was to say, oh yeah, so we did some analyses that had to do with looking at differences between the two conditions, the high power poses and the low power poses, particularly on participants' self-reports of the power that they perceived, okay, like self-reported power. And it turned out that they had like 10 different questions or something like that. I'm sorry if I'm messing it up. Seems irresponsible, but they had a number of questions that they asked participants, and they just happened to select the question that worked and report that. They failed to report the other 7 or 8 or 9 questions where they didn't find the effect. It would seem to me, in full transparency, that when you're reading a research report, it would be valuable to know, okay, so did these power poses affect the way that people felt about themselves? Well, we asked them 10 questions, and it seemed to affect the way that they felt in terms of their answers on this one question, but not the other ones. And now, those of you that are reading our paper, you can make your own judgments as to what you think about that. But, full transparency, these were all the questions that we actually asked, and these were all the analyses that we actually did. We're not just like selectively reporting some of it. So that would be a good thing. There's the practice of open science, which is sharing one's data and materials freely so that others can collaborate, use, and verify the results. I recently published a paper, and the journal said, we would like for you to share with us the data set that you used to analyze and present your results. And this is so other researchers can say, I'm going to look at those exact same variables. I see all the variables in the data set. I see everything. I'm going to try to do the exact same thing. Or I'm going to say, I think that Armovich character should have included this additional variable as a control. Like they can do that. Okay, so open science. And then there's the improvement known as pre-registration, which is that you can, some statistical journals allow a researcher or a research team to pre-register the study's method, hypothesis, and proposed statistical analyses in advance of collecting the data. And so essentially what the journal is doing is saying, hey, we think that you've designed a good study. So long as you collect the data in the way that you propose to do, and you analyze the data according to what you propose to do, will publish your research study no matter what happens. If you get a statistically significant result, great. If you don't, that's fine too. Okay, so pre-register it, and if we think you've designed a good study, we'll agree to publish regardless of what the results are. So that's an important improvement. All right. In terms of replication, I think that in just trying to understand just how strong of a phenomenon are we talking about, meta-analysis is an important technique. And so what a meta-analysis does is it looks at the scientific literature, aka the literature, okay, which is a series of related studies conducted by different researchers that have tested similar variables. And then you can do a meta-analysis, which is a statistical analysis that yields a quantitative summary of a specific literature. So among all the studies that have looked at differences, I'll just do an example. Among all the studies that have looked at the differences between men and women in, say, leadership style, let's take that whole scientific literature, okay, the entire scientific literature around, are men or women better leaders? Let's look at style, let's look at behaviors, let's look at the perceptions of their followers. Let's look at that entire literature, and let's do a statistical analysis of the empirical studies done in that literature. Okay, so are men versus women, or are women versus men, are they more participative leaders? Okay, that is, are they better at involving their followers? You can do a meta-analysis on that question. You find all the research studies that have included those variables, okay, that have tested that question, either because that was the main thrust of the study or because it was one finding out of many in a study. And then you take all the results and then you try to summarize the extent to which that effect is present. And the answer is, like, just a little bit, by the way, that women are ever so slightly more participatory than male leaders, but it's like a negligible effect. So this is just a table from the study. I don't think I'm not going to spend so much time with this because it's in the book, but this is just a way to say that we've got a research phenomenon. Okay, fine, I'll review it. So we've got results for reaction time difference between lying and truthful condition, categorized by type of instruction to participants. And so a group of researchers, apparently there's been a lot of studies out there about whether people are faster or slower to respond when they're giving a truthful response versus a lie. Okay, I guess it's kind of interesting psychologically because it's like, can you catch somebody in a lie? What they have to do is they have to search databases to see all the journals that have published studies that have looked at this. You email colleagues, you go to online groups, you say, hey, have you ever done a study that had to do with the response time and trying to determine whether people are telling a lie versus telling the truth? If you have, and you haven't published it, I found it if it was published, but if you haven't published anything, let me know. That's known as going into the file drawer. And then what they do is they take all those results and they calculate the effect size. This is known as a Cohen's d. A Cohen's d is a measure of effect size between two different groups or conditions. It basically expresses a difference in terms of standard deviations. Okay, so you could say that there's a 1.29 standard deviation difference between the response time in the lying and the truthful condition, with lying being slower than truthful. But you also notice that they segmented these results because they noticed that in the literature that they looked at, there's a difference in instructions. And there's 100 studies in which participants are instructed to go as fast as possible, 11 in which they're given no such instruction. And you can see that the size of the effect seems to matter just a little bit on that instruction. Okay, so anyway, that's an example of a meta-analysis. It's trying to come up with an overall summary statistic, which gives a sense of the strength or size of the phenomenon. And then there's other types of metrics that they pull out too, which have to do with the generalizability of the finding. And of these studies, the average effect is that lying is slower than truthful. But of these 100 studies, there's some that don't find an effect at all. Some find a much bigger effect. So it gives you like a sense of the range and all that kind of stuff. Now, I had referenced this idea of the file drawer problem, and in doing a meta-analysis, it's important not just to look at the published literature, but to send emails out to different research groups, different professional societies, and say, look, if you've ever done a study but you haven't published it, please send it to us. Because in attempting to establish the reliability as well as the strength of the phenomenon, it's important to consider both published studies as well as non-published studies. Because, of course, no results or results that are in the opposite direction, okay, where, oh, well, our study found that people that were telling the truth went slower. That's weird. We must be wrong. Throw it out. Okay, it's rarely published. But it could be, unbeknownst to everybody, that there's all these kind of studies, and there's maybe a smaller but non-trivial amount of studies that get the opposite result. And so that speaks to both the reliability as well as potentially some boundary conditions. Like, well, what's going on with some of these studies that found the opposite result with people that are telling the truth have a longer response time? Is there some common thread in those studies? So it's very important to dig into the file drawer. And what was I going to say? So, and the example that was given in the book had to do with it looking at the effectiveness of antidepressants. Okay, using words, working on it. Okay, looking at the effectiveness of antidepressant medications on depressive symptoms. And so what they were able to find was 74 studies, and it turned out that 38 studies showed a positive effect of antidepressants on positive symptoms, that is, reduced the positive symptoms. But 24 showed negative results, and 12, as in it didn't work, and 12 showed questionable results. All of the studies, or at least all but one, with the positive results were published in the medical journals, but the no results weren't published. So if you look at only the published studies, basically 94% of the published studies show that antidepressants are effective. But if you look at all of the studies that are considered, it was only 51% of the studies showed that antidepressants were effective. So you really get a biased view of the phenomenon, and something like this, really overestimates the extent to which antidepressants are effective if all you're doing is consulting the published research literature. We should be cautious. I'll say this, that if that there can be reasons that studies get no results. Sometimes the reason that studies get no results is because they're not done well. That can be one reason. Other times they're done perfectly well, they just get a null result. So we still have to be critical of null results. And critical meaning like not blame them, but just means we have to scrutinize and try to understand what's going on. Certainly the media is to blame. Oh yes, of course, the popular media. Journalists want people to read their articles. And of course they're going to go with something that is new and flashy and gets people excited. Okay, if you've watched John Oliver's segment on this about the replication crisis, some of the findings about all the good things that like chocolate will do. If you just eat one piece of chocolate, you'll lose weight, or if you just drink a glass of wine, you'll lose weight, right? You got like these single studies that come out and have the finding, and boy, let's print that, because if I can write that article and I can say that a study was done, I'm going to get a lot of clicks on my blog or a lot of people that are reading my article. let's not bother to see whether that is a replicable finding. Nobody cares. People just want, like, the diet pill that's going to make them lose a bunch of weight and be better looking. Quick fixes. So let's just write things that sound good, that are exciting. Now, of course, I'm being as cynical as possible. There are responsible journalists out there. I've read popular press stuff where they've done a very good job reporting on the scientific literature. And those people do summarize the body of literature. So the new results that come out, there is some sense in which it's taken in context. But I do think, and I hope, as students of research methods and having taken this class, you will be just maybe a little bit more critical and skeptical when you read things on popular press sites. So like in psychology, that might be the Psychology Today website. And to just ask yourself, is the author, just as one example, I guess I'm picking on him, but not really, okay, is just to read the article and say, do I think that this author has done a good job at summarizing the entire research literature? And they're kind of talking about a recent finding from a single study, but have they mentioned kind of, what the rest of the evidence says? Or are they just really having me focus on this one finding that I don't know if I can trust it or not? So, I hope that you will read with a little bit more of a critical eye. It doesn't mean that you shouldn't trust anything. Okay, I'm not encouraging that, but I'm just saying you should be a little bit more skeptical. Now, to be important, does a study have to have external validity? And so here's 4 considerations that I'll review, which is generalizing to other participants, other settings. Does it have to be generalizable to many people? And does it need to take place in a real world setting? So in terms of generalizing to other participants, it's important to keep in mind that we're referring to whether or not the results generalize to a population, not the entire population of the entire world. Okay, so a population is simply the population of interest, just the folks that we'd like our results to generalize to. So it could just be like all college students, okay, or maybe all college students in the US. Okay, and so if there's some finding that has to do with looking at, say, academic motivation as an example, or academic performance in college, and there's different like personality variables that are looked at, or different family variables that are looked at, or different types of educational programming or interventions or something like that. The goal would be simply to generalize either to all college students or maybe to different segments of college students, maybe first-time college students. So things like that. It's to keep in mind the results are only meant to generalize to a population, not every single person in the world. All right. And external validity really comes from how, not how many. So it really has to do with how a sample is obtained. When there's random sampling versus like biased or convenient sampling, that's more important than how many participants are in the sample. In other words, you could have a large number of participants that are gathered in like non-probability ways, that are gathered in a biased way. And a large number of participants that are gathered in a biased way doesn't enhance external validity. And then the last thing is that just because a sample comes from a population doesn't mean it necessarily generalizes to that population. So, like, for example, it's incorrect to assume that just because a convenience sample includes some member of a population, that it generalizes to everybody in that population. So convenience samples, for instance, can be self-selected people. So it's often the case in psychology that we do research studies where we recruit college students, and we recruit college students who often participate on a voluntary basis. So as a convenient sample, there could be something specific, different, unique, and non-generalizable about people that volunteer to be in psychology studies, and they're inherently different than people that don't. So just because you've got a subset of people that come from a population, it doesn't mean that they're the same as everybody in that population. The idea of generalizing to other settings is ecological validity. So this is just an aspect of external validity in which the focus is on whether a lab study generalizes to a real-world study. Ecological validity is also known as mundane realism. And so it's just one example. Maybe you're interested about investigating lying when playing poker. That's what people are interested in, let's just say. Simple example, okay? Maybe what characteristics of a person or what behaviors are displayed when people are trying to, maybe lie or bluff when playing card games or poker. There's certainly more ecological validity in mundane realism if you're able to study that in a real world setting where there's other people that they're really playing with, okay? There's maybe like real stakes, like real money, versus say doing that in a laboratory setting on a computer, okay? So that would just be an example of ecological validity. Another example would be looking at, say, maybe you're interested in different types of employment decisions. One thing that you can do is you can have participants come to a laboratory type environment and evaluate candidates for some hypothetical job. And then you give them a bunch of resumes and you say, hey, would you hire this person or would you hire this person? And you've kind of systematically changed different features of the resume, okay? And indeed, people do this and they keep all the information on the resume the same and they just change the name and the name only. And so it's either a male name or a female name. And then they look at the percentages of, say, men versus women that people say that they would hire for a job. But you can do that in a laboratory setting. Or what some creative researchers have done is they have actually done that experiment by sending in resumes and cover letters to actual people that are actually hiring for jobs. So professors, for example, that have research labs and they're recruiting for research assistants and they're actually going to hire that person. Those studies have also been done, and then unfortunately what is found is that exact same resume, exact same information, female college students that are applying to be research assistants in science-related laboratories are selected less often than men. So certainly that one has more ecological validity in mundane realism because it's actual people thinking that they're actually making those actual decisions. Not thinking, they're actually making those actual decisions. So does a study have to be generalizable to many people? I think it depends on the priority, and so here's just some of these considerations. It depends on whether the priority is to test theory versus actually wanting to generalize, and so that's what your textbook author describes as generalization mode. Cultural psychology is another example of wanting to be in this generalization mode to say, to what extent do these theories and concepts generalize to other cultures? And then whether it's, kind of testing theory but using convenient samples, which are known as, well, I'll just say what this acronym means, a little bit weird. All right, so theory testing mode. The short of it is that when the goal is to test theory, generalizability takes a back seat. And so some of the examples that you've encountered in this class would be testing the theory of contact comfort. You'll recall that this was Harry Harlow's study. He had the infant monkeys. He wanted to test whether basically the little baby monkeys would spend more time on the mother that provided the milk but no comfort, okay, the wire mother, versus the one that provided comfort that had the fur. So this was not meant to generalize to necessarily to all people or humans. It was just it was an original test of a theory to say, is there anything worth pursuing here? Am I on the right track? Is this a reasonable theory in the first place? So it's all about testing the theory. Another example was the parent as grammar coach theory, which you might remember if you read it in the book. But here, these authors were in theory testing mode, based on trying to understand how children learn grammar. It turns out that the reinforcement theory of grammar states that children learn correct grammar through reinforcement. They tested the theory by listening to audio tapes of parents and their children interacting, and they found that most of the time the parents corrected the children's speech for factual accuracy, but not for grammar. Okay, and it turns out that that did not support the reinforcement theory of grammar. But the participants in the study were primarily upper middle class, and they came from the Boston area, so not necessarily representative of all families in the United States. But that's okay, even though they had a non-representative sample, and you could say biased in a way because it was a convenient sample. They were still testing a theory. And so they were less interested in the external validity. And so maybe it doesn't generalize to all populations, maybe there's boundary conditions, but they were saying, we want to know if this theory has any merit. So we are going to use this non-probability sample, but we don't think that that hurts us in terms of our ability to make conclusions about the viability of the theory. Now, kind of at the opposite end of the spectrum or continuum, certain research really focuses on the generalizability of the finding. Like, that's the most important part of the research. And that's primarily found in studies that are investigating frequency claims. So research that would want to know what percent of college students choose to live in the dorms, or what percentage of voters are going to vote for the Democratic candidate versus the Republican candidate. It is very, very, very important to have large and representative samples, because the whole point of a frequency claim is to be able to generalize. So take that sample to come up with that number or that frequency, and to trust that as being representative of a larger population. When it comes to association and causal claims, sometimes is used to really be in generalization mode and to see whether these association or causal claims can be generalized to other populations or other conditions. Most of the time, though, causal claims are involved in experiments, and experiments are done to test theories. So, they're more often found when researchers want to test theories. However, we've talked a bit about looking for different moderators, looking for boundary conditions. And so once a causal claim has been established, other researchers will then look at the boundary conditions around that causal claim. And that happens frequently in cultural psychology or cross-cultural psychology. So cultural psychology is a subdiscipline in psychology that focuses on how culture shapes human thinking, feeling, and behavior. So most cultural psychologists tend to emphasize the importance of whether effects are generalizable across different cultures. So here's just one example. So this is known as the Mueller-Lyer illusion. I don't know if you saw this in Psych 101, but basically, so looking here, which of these lines looks longer? It should be the case that this middle line looks a lot longer than this top line, but it turns out, okay, this is, I copied it, a one for one, that if you really look, the length of the line where it ends at the point here is this top line is exactly the same as this bottom line. Okay, I know some of you might still not believe me, but it's true. So it turns out that this is a cross-cultural phenomenon. Cognitive psychologists, people that study sensation and perception, believed for a very long time that this was a general effect, that all human beings have this illusion, and it's just a general perceptual illusion, and it's universal, like everybody experiences it. But it turns out that it's North Americans and Europeans that say that this middle line is longer than the top line. But if you look to the results in the right in this graph, you'll see that many people around the world don't necessarily see line B as being longer than line A. So what's going on here? It turns out that there's people from other cultures that live in buildings that aren't based on the same carpentry that we have in North America and Europe, that don't have the straight lines and the edges. And so because we have them, we have experiences with these right angles as cues for depth perception, and that is some of the basis of the illusion. But other people in other cultures where they're more used to buildings and home structures and things like that are round and don't have the right edges, they just don't, their eyes are literally not trained to see the same thing. So this is just one salient example of a cross-cultural phenomenon, and one in which cross-cultural research would want to really look at the generalizability of certain psychological findings, to say, can we really call it a psychological universal if we don't see it in other cultures? Another great example comes from social psychology, and it's known as the fundamental attribution error. Okay, it was called the fundamental attribution error because social psychologists were so convinced of the prevalence of this error. And basically what the error is that people are more likely to attribute the reasons for people's behavior as residing within them as opposed to the environment. Okay, so why is that person doing that thing? It's because of who they are. Why is that person driving so fast down the interstate? It's because they're just an impatient speed demon. Okay, it's an internal cause versus an external cause. Oh, they must be late for work. Okay, and that's just kind of a silly example, but that generally illustrates the phenomenon. The fundamental attribution error, we are more inclined to make attributions for other people's behavior that originate from causes that reside within them, their personality, their disposition, their values, whatever it is, instead of external causes. And that was called the fundamental attribution error because everybody did it, except everybody doesn't do it. Cross-cultural psychologists determined that in other cultures, predominantly East Asian cultures or collectivistic cultures, people from China, Japan, Korea, etc., are much more likely to make environmental or situational attributions for a person's behavior. And generally speaking, very generally speaking, I hate to oversimplify it to this degree, but in those cultures, there is more of a focus on the group, the collective, and so people more kind of naturalistically are used to explaining or attributing the reasons why people do things to more external reasons or causes. All right, so it's worth, I guess maybe a good segue to bring up this point, which is that many of the theory testing type papers that you will read in top tier psychology journals are based on findings from data that come from weird participants. Okay, these weird participants are college age students in North America, primarily the US and Canada. And they're weird because they're Western, educated, industrialized, rich, and democratic. So I believe in one study of this phenomenon, of the top 6 psychology journals in a particular year. It was either 2007 or 8, I forget. 68% of the participants were American and 96% were from North America, Europe, or Australia. So certainly these participants from these countries are very different than participants in the rest of the world. Although I'm quite sure that when it comes to generalizability, there's quite a few psychologists that are doing research with these convenient samples, and they're probably thinking about generalizing their results to people in general, not really considering people from other countries, cultures, etc. As that example about the fundamental attribution error suggested, and indeed the fundamental attribution error was research that was done in the 60s and the 70s, some in the 80s. I mean, decades of research, but using primarily North American college students. And it wasn't until the 90s that cross-cultural researchers said, I don't think it should be called the fundamental attribution error because I don't really think that people in Japan and China do this. So we should be somewhat cautious when we read the psychology journals that we're used to reading, that quite a bit of the established theories that we know of today have been based on decades of research, but only among these weird participants. Just kind of wrapping up, just a couple more points in terms of external validity and the real world. When a study takes place in the real world, that is like outside of a laboratory, it takes place in a field setting. It has high external validity, but it should be stated that laboratory research can be just as realistic as research conducted in a field setting, and this is known as experimental realism. I spent my time in graduate school doing research that was primarily laboratory studies. I can say from first-hand experience, and I am only just a data point of one, so you can take it for what it is, but it is very much the case that in a laboratory environment, you can still design an experience and tasks that are very engaging, that people kind of forget where they are. They kind of get into it. And so that is known as having a high degree of experimental realism. Yes, it lacks the elements of external validity, but that doesn't mean that people aren't really there and engrossed in the phenomenon and what they're doing. So it can still have a high degree of experimental realism. When working in generalization mode, it's important to have a representative sample for high external validity. So that's important. Okay, representative samples, very important when external validity is the goal. Ecological validity is very also important to consider in terms of generalizing to non-laboratory settings. So that is, if you do a lab study, does it try to bring in aspects of ecological validity? Can conditions be created in a laboratory environment that really make it seem like you're out there in the real world? When in theory testing mode, external validity and real world applicability are not as important. They do take a backseat. Okay. All right. So quite a bit there, but I hope that after hearing this lecture, you've got a better sense of some of the issues related to replication, especially in psychology, some of the concerns around the replication crisis, as well as some ways in which studies can be replicated, but really all the issues around there. Have a better sense of the importance of generalizability when it takes a kind of a front seat and when it goes to the back seat.